Okay, so this is lesson 7.6, which is solving problems involving the area of a regular polygon. So notice it has the word regular. So let's review what it means to be a regular polygon. It's a closed shape that is equilateral and equiangular. Okay, so the strategy that we're going to use today, and I'll reference it once we get to number 2, is to find the area of a regular polygon. We're going to break it up into triangles and find the area of the triangles, multiply it by how many there are in the figure. So again, I'll come back to that when we talk about number 2. So first let's find the area of the regular triangle. Again, regular means it's equilateral, all sides are equal, and equiangular. So remember, a triangle that's equiangular, all the angles are 60 degrees. For now, I'm just going to label the bottom 2. So we need to find the area of this triangle. Area is base times height divided by 2. The base, right? The base we know is 10. However, what is our height? We actually don't know at this moment. But I'm going to go ahead and draw this line. And in an equilateral triangle, or technically in an isosceles triangle, this line will bisect this segment, making it 5 and 5. And it also will bisect this angle, making it 30 degrees. Notice this is a 30, 60, 90 triangle. X, 2x, x square root 3. So we need to identify what's been given to us, which is the hypotenuse. So this equals 2x, which means that x equals 5. So this side is 5, which makes sense. And this side is 5 square root 3. Now I know my height, which is 5 square root 3. So area equals base, which is 10, times the height, which is 5 square root 3, divided by 2. Reduce whenever you can. So 10 divided by 2 is 5. And multiply. 5 times 5 is 25. Square root 3 feet squared. So, number 2, the more difficult one. We're going to find the area and perimeter of the regular hexagon. So that means all these sides are congruent, and I'm not going to mark up the angles just yet. We're going to break it up into triangles. So take a moment. We're going to go from this center, this is the center, out to each of the vertices. And so what we've done is we've created 1, 2, 3, 4, 5, 6 triangles. So to find the area of this shape, we're going to find the area of one triangle. Okay, so we're going to find the area of a triangle, and then we're going to multiply that by 6. Okay, so we'll come back to this in a minute. So let's just focus on finding the area of this triangle. If this is 12, that means that this is also 12. Okay, we need to figure out what the measure of this angle is. So I'm going to take a moment, go to the side and do some scratch work. So from the launch in number 2, I believe, or number 1, we know that these 3 angles will add up to 180. These 3 angles will add up to 180 because they form a straight line. See that? A straight angle. So 180 plus 180 is 360, right? So all of these will sum to 360. They're also all the same exact measure. So 1, 2, 3, 4, 5, 6x will equal 360. So divide both sides by 6. And we know that that central angle is what it's called. This is 60 degrees. Okay? So now, because this is an isosceles triangle, technically these base angles are also congruent, which makes this, amazingly, a 60, 60, 60 triangle. Okay. So now let's go to the side. We're going to redraw our triangle out here. We know that this angle is 60 degrees. We need to find the area of it. So in order to find the area of a triangle, it's base times height divided by 2. This is our base, right? Oops, wrong color. This is our height, which is actually right there. And then we'll divide it by 2. So we found out that this is an equilateral triangle, so this is also 12. I'm going to go ahead and substitute that in now. We need to find our height. It's a 30, 60, 90 triangle, so this now is 6. This is 12, making this 6 square root 3. So our height is 6 square root 3. We'll divide it by 2. Divide it any time. 12 divided by 2 is 6. So the area of this triangle is 36 root 3. Again, the area of this triangle equals 36 root 3. Okay. Now we're on to part 2. We've found the area of the triangle. And there are 6 of them. So this is 36 root 3, this is 36 root 3, 36 root 3, 36 root 3. So the area of the entire polygon will be 36 root 3 times 6, because there are 1, 2, 3, 4, 5, 6 of them. So 6 times 36, 36, 18, 19, 20, 21. Will be 216 square root 3 centimeters squared. Okay. We're going to do that one more time. Pay attention to the process. Okay, so we need to find the area and perimeter of the regular pentagon. Regular. So step 1, find out how many triangles are in this. Okay, so ultimately we're going to find the area of one triangle and we'll multiply it by 1, 2, 3, 4, 5. Okay, so let's find the area of one triangle. This is our given information. Okay, we need to find out the central angle measure. We need to find out what this measure is. So to do that, we know that there are 1, 2, 3, 4, 5 central angles. So 5x will equal 360. Divide both sides by 5. Okay, so we're going to do 360 divided by 5. Goes into this 7 times. 5 goes into 10 twice. So x equals 72 degrees. This is 72 degrees. Okay, now if this entire angle was 72 degrees, do one more thing, then this angle will be 72 divided by 2 because it's bisected, okay, which is 36. So that is 36 degrees. Now, in order to find the area of our triangle, we need to know the base, which right now we don't know. Multiply it by the height, which we do know is 12, and then divide by 2. So our goal right now is to find the length of this whole segment. Notice that we have a trig box here. If we can solve for this, this is the same length. This is the opposite side. This is the adjacent side. So I know that I'm going to use the tangent of 36 to solve for that segment there. Do that right below. Tangent 36 is equal to opposite, which is x, divided by adjacent, which is 12. substitute in 7/10, cross multiply, 10x equals 7 times 12, which is 84. Divide by 10, which means we move the decimal place over 1, 8.4. This segment is 8.4. This segment is 8.4, which means, and I'll do this above, the whole base, 8.4 plus 8.4, which is 16.8. Rewind if you didn't know what I just did and listen to it again. So the base is 16.8, the height is 12, and we'll divide this by 2. I'm going to choose to divide this by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. Go to the side and do some scratch work. I'll come way over here. 8.4 times 12. So we're going to do 4 times 2, which is 8. 4 times 1, which is 4. 8 times 2 is 16. 8, 9. Move the decimal place over 1. So 8.4 times 12 is 100.8. That is the area of this entire triangle. So we're going to take the area of the entire triangle and we're going to multiply it by 5. One more time, scratch work. 5 times 8 is 40. 0, carry the 4. 0, 5. Move the decimal place over 1. The area of this regular pentagon is 504 centimeters squared. Go back, rewind if you need to check and understand this problem a little better.